Good evening, all of you. Today we will see a problem based on magnetic field, magnetic flux density. Class 12 physics. The question is calculate the magnetic field at the center of a square loop which carries a current of 1.5 amps, length of each side being 50 centimeter. So the answer for this problem is approximately 3.4 into 10 power minus 6 Tesla. We will see how to solve this problem. So we already saw that this is a current carrying wire, the current is I. We are interested the magnetic flux density or magnetic field at the point P. So the points of consideration is this point which is y and this is y dash. So this is the length of the current carrying conductor. Now this from this point with P, this makes an angle pi 2. So this is 90 degree and this makes an angle pi 1. And what is A? A is the length between this point and this point. This is length. So this length, so if I call this as capital A, length is AP, which is small a. For this we have already derived an equation, formula for that. So the magnetic field B vector is equal to mu naught I by 4 pi A into sin phi 1 plus sin phi 2 into n cap, unit normal vector. So you must know the derivation of this and the final result. So we are going to make use of the final result. Okay. Now this is the square loop. It is given as square loop. And the current flowing in this conductor is 1.5 amps. Okay. Now we just make a diagonal BD and CA. Now if you consider only this part alone, this resembles this diagram. Okay, same. So this angle is phi 1, phi 2 and this is phi 1. But in this case, the total degree around this is 360 degree. So it is divided into 4 because it is a square. It is given as square loop. So this has to be 90 degree. This has to be 90, 90 and 90. So totally you will be getting 360. Why I am telling 90 degree? Because it's a square. So definitely this angle totally should be 90. Also phi 1 is equal to phi 2. So this is going to be 45 and this is also going to be 45 because it is a square loop. So now we know the current A. A is the distance between this point and this point. This point and this point. Here this point and this point. This is center of this AB. The total length is 50 centimeter. So half of it will be 25 centimeter. For 25 centimeter, I have written 25. Centi is 10 power minus 2. So by making use of this formula, I am going to solve. So first we will consider only the length of wire AB, where current 1.5 amps flows here also. Okay. So mu naught is 4 pi into 10 power minus 7. Current we know 1.5 divided by 4 pi A. A is this length. This length I just now I told you it is 25 centimeter. So 25 into 10 power minus 2. So that will give you the answer in this in meters. Then sin phi 1 plus sin phi 2. Phi 1 and phi 2 both are equal. So sin 45 plus sin 45. So if you simplify and get the answer, you will be getting for this length AB. So but we have to consider the entire loop. So totally we are considering only the magnitude of the magnetic field. So if you multiply this answer with 4, you will be getting for the entire loop. So B vector for this path alone. So if you multiply by 4, here again you have to multiply by 4. Multiply both sides by 4. So that means you are considering the entire loop, entire square loop, and you are interested the total magnetic field at the point P. Okay. So 4, so rest of the thing will be as it is, 4 pi into 10 power minus 7 into 1.5 divided by 4 pi into 25 into 10 power minus 2. Sin 45 is 1 by root 2 plus 1 by root 2. Okay. So 1 into 4 pi will get cancelled. And if you do the simplification, you will be getting 3.3936 into 10 power minus 6 Tesla. Otherwise, you can write V bars per meter square. Okay. So T means Tesla. So this can approximately can be written as 3.4 into 10 power minus 6 Tesla. So this is how you have to solve this problem. You are interested in the total magnetic field at the point P. You are considering only one side and you are comparing with the standard result, and then you are multiplying by 4 just because it's a square loop. Even if you consider this side, you will get the same result. So for one side value, you just multiply by 4, you will get the magnetic flux density at the point P because of the 4 sides, because it's a square loop. Thanks for watching this video. Nandri.